Okay, so first thing that we're going to do is we're going to work on our practice here. So do it yourself, try it yourself, do it with pencil or do it on your whiteboard. And then double check your answer as you go in. Okay, I recommend you just do a question or two at a time. Don't do it all, then come check out the video, realize, oh, I've been doing it wrong the whole time, right? Check as you go. You're wasting your time if you're not checking as you go. Okay, so question one, calculate the slope of the two lines on the graph, which is steeper. First off, what's steeper mean? I already know that line 2 is going to be steeper just by looking at it. But I need proof of it. So what I'm going to do is let's figure out line 1 first. So line 1, see how it's L1? So line 1, I need to figure out the slope of these two lines. So I have 2 points on a line. I'm trying to figure out the slope. What do I need to do? I'm not sure. Let's look back in our notes. Oh, I see that we took notes of how to calculate the slope of a line using any 2 points with this formula. M is equal to y2 minus y1, all divided by x2 minus x1. Let's go work that out. So first thing I always do, put your freaking formula in, right? My slope, M, is equal to y2 subtract y1, all divided by x2, all subtract by x1. What the heck is this x2 and x1 and y2 and y1 mean? What the heck does that mean? So first off, the x and the y, right? We always denote points on a graph by x and y. This point right here, this is my x-axis here. This point, I can see goes 1, 2, 3 on the x-axis and goes up 1 on the y-axis. So this point here would be a 3 to 1, right? So just as a quick refresher there. So that's how I figure out what x and y are. Now, we read a graph left to right, just like how you read a book. You read from the left to the right. If I'm starting with L1 and I'm reading from the left to the right, I can see that, oh, this is the first point I see here. I have a point that is 5x and a 3y. This is a 5 to 3 point right here. And I keep going. So first off, this is the first point I see. This is point 1. So this is x1. This is y1. I keep going. All of a sudden, I go right here. Oh, okay. So now this is my second point. This is the second dot I see. And I can see that this is an x of 10 over a 6y. It's okay. I now have my points. So now all I need to do is substitute these in, right? So m is equal to y2, 6, subtract my second y, 3. Sorry, my first y. So 6 subtract 3. My x squared, my x2 here is 10. My x1 is 5. Now all I need to do is just substitute that in. Okay, so that's a 3 over a 5. This is my slope of line 1. Cool. I have this slope. It is 3 over 5. Cool. That's the label of this line. Now let's do L2. Same thing. I'm using 2 points to figure out a slope, which means I know I need to use this formula. It's not about knowing how to use the formula. It's about knowing when to use it as well. That's a mistake a lot of students make, right? So that's how I know I need to use this formula. And now we're going to use the formula correctly. So y2 minus y1, all divided by x2 minus x1. So I'm reading L2, right? That's this line. So if I go from left to right, left to right, left to right, oh, there's point 1. It is 1, it's a 2x. So my x is 2. My y is 1, 2, 3, 3. I keep going up this line. I see another point, right? The x of this point is 6. The y of this point is 9. So it's 6, 9. Nice. So what we need to do then is we just need to substitute everything in. So m is equal to my y2 is this thing, right? Because it's the second point and it's the y of it. So it's 9 subtract y1, which is 3. 9 subtract 3 on the top. On the bottom, which is my run, that's my x's, right? My second x is 6. And then my x1 is 2. So 6 subtract 2. So simplified out, I get 6 over 4. I can simplify that into a 2 over 3. So I have a 3 over 5 and a 2 over 3. Which one of these is steeper? Well, again, I look at it, I can see this one's steeper. If I wasn't sure, I would have to get these into the same common denominator. So I'm just going to bring those up here. So I have 3 and 5 for L1, and then for L2, I have 2 and 3. So 1, you could just use your calculator for this. You could figure out what 3 over 5 is. That's going to be 0.6. This one's going to be 0.66. But what we're going to also do is we're just going to get them to the same lovely denominator here. So cross multiply, right? So I need to times this side by 3, this side times 5, or you can use your calculator. That's fine too. I'm going to get 9/15 for L1 and 10/15 for L2. Okay. So this is saying that rise over run, right? I go up by 9 for every 15 I go across, or I go up by 10 for every 15 I go across. This is a steeper line. Okay. Okay, so let's keep going here. Question 2. Calculate the slope of the 2 lines on the graph. Okay. So same thing as normal, right? So let's do L1. I have 2 points on a graph. I need to try and find the slope. I need to use my formula. M is equal to y squared minus y, or y2 minus y1, x2 minus x1. Okay. So L1 here. So I have 1 point here. This is a 2 on the x and a 6 on the y. So 2 and 6, this one. And then the second point, this is point 1, is going to be a 9 on the x. But oh, it's just going a flat line. So it's going to be the same y. This is my point 2. So first off, this line is different in that there is no vertical change for line 2. So y2 minus y1 is 6 subtract 6, right? And then x2 minus x1 is 9 subtract 2. I get 0 over 7. So what this slope means is that I go up 0 for every 7 I go across. So this line is always going to stay flat forever. So now L2, line 2, same thing. 2 points I need to try and find a slope with. I know I need to use this formula. So slope M is equal to y2 minus y1 all over x2 subtract x1. I apologize, it's kind of messy writing here. I don't have a lot of space to move my mouse. So let's label our 2 points. So this is L2 here. Read it from left to right and up to down. Kind of tricky there, right? We haven't had to do this before. So left to right, doesn't really matter which one I kind of start off with here. I'm going to start off with this one. My x is going to be 4. My y is going to be 2. My second point here, remember we go from left to right and up from the bottom to the top. My x is going to be 4 because it hasn't moved from this point, and then my y is going to be 9. So substitute our values in, right? My second y, the second point, is going to be 9 subtract 2, and then the x's are going to be 4 subtract 4. This is going to all equal out to 7 over 0. This is my slope, right? Leave it as a fraction. So it goes up 7 for every 0 it goes to the left or right. And we can see this is true because this line just only goes up and down. Okay. Number 3, on the graph below, draw these 2 things. So a solid line that passes through point A and has a slope of 6 to 5. And then we have a dotted line that passes through point A that passes through, that has a slope of -3 to 2. So first off, we see this as positive. So I know it's going to go up as we go left to right. So we're doing point A here, the one with a slope of 6 to 5. So why don't we start from this, right? So this is rise over run. I rise 6 for every 5 I go across, okay? So let's do that. So for A, so I rise 6, 2, 3, 4, 5, 6 for every 5 I go across. 1, 2, 3, 4, 5. Put your point in. Now I have 2 points, right? I can draw a line. So I'm going to draw a solid line that goes to this. You should be using a ruler for this. I don't have one because I'm on a computer, but I did the best I could. Label it. This is 6 over 5, right? That's the slope. This is line A. Okay. Now I'm going to do a dotted line that passes through point A that has a slope of -3 over 2. It has a negative slope, so I know it's going to go down, right, as we go from left to right. So -3 to 2, okay? So that means it's going to go down 3 for every rise over run. So the rise is 3. The run is going to be 2. So it goes down 3 for every 2 it goes across. Boom, I have another point here, right? Okay, so now all I need to do is draw a line connecting these two. So dot, 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 dot. Again, not very good. You should use a ruler for it, but label your slope, -3/2. This is line B. Done. Use the slope, count it out. You see how I counted it out for both of them? Do it. Okay, question 4. Reggie is starting to practice for a marathon. If he walked 3 kilometers in 30 minutes, what's his average rate in kilometers an hour? Okay, so first off, it's asking me in hours and I have minutes. What do I need to do? Convert your minutes. This is 0.5 hours, right? 30 minutes is 0.5 hours. So, so he's starting to practice for a marathon. So if he walked 3 kilometers in 30 minutes, what's his average rate in kilometers an hour? I only have 2 points here. So I only have 2 things. I'm not trying to find an angle though. I'm trying to find an average speed. So first off, let's put this into kilometers an hour, right? Why don't we do that? So I know I get 3 kilometers over 30 minutes. Or sorry, not 30 minutes, over half an hour, 0.5 hours. Okay, so now I have it in the format they want, but I'm trying to figure out, I'm just going to erase this. I am trying to figure out, however, how many kilometers does he walk if I walk 1 hour, right? Because that's how we measure kilometers in an hour. It's 1 hour. So what number did I take 0.5 and times it by to get to 1? You could eyeball it, see that it's 2, or you could take 1, divide it by 0.5 to figure out how many times it goes into it. 2. So take that 2, times that by your 3 here, you're going to get 6 kilometers. So the answer is 6 kilometers per hour. So what is the independent variable? Oh, shoot, what's an independent variable? I know, I'm going to go up to my notes and take a look at it. So go flip back, look at your notes. That's why we do them, guys. What is an independent variable? A variable whose values may be freely chosen. And a dependent variable is a variable whose value relies on the value of other variables. It's dependent on other things. How much money you make is dependent on your salary and how much you worked, right? So the independent variable of these 2 things is actually going to be the time. It's going to be the time because how far he travels is dependent on his speed and his time. But you could say he ran for 2 hours, he walked for 5 minutes. Either way, he has an average pace. So the independent variable in this case is going to be the time he walked. Okay. And so question C, if he does not change his pace, how long will it take him to walk a 36-kilometer marathon? There's a couple ways you can do this. Way 1, set it up as a ratio, right? I know I'd go 6 kilometers in 1 hour. So how long would it take me to go 36 kilometers? This is way 1. You could just figure out what number 6 times something gives me 36. You could figure that out. It's going to end up being 6, which means you take this side by 6. So it takes him 6 hours. That's way 1. Way 2 is, you know that he takes 36, distance traveled is equal to speed times time, right? So I know it takes him 36 kilometers. Just using logic, it took him 36, he traveled 36 kilometers, and I know it takes him 6 kilometers an hour. So you can just divide it out and use logic. Oh, well, it's going to take 6 hours then. That works too. Just show me how you got the answer. Okay, question 5. Janina's car needs repairing, and she borrows $600 from her brother to pay for the bill. She repays her brothers back $40 a week. Write an equation that shows the relationship between how much she owes her brother and how much she pays each week. Well, so first off, the total owed is going to be write an equation that shows the relationship between how much she owes her brother and how much she pays each week. So the total owed is going to be, first off, she owes $600. And if she's taking away $40 a week, isn't that just $40 times number of weeks, right? Cool, I have a formula. If it's 2 weeks, you'd put 2 in here. If it's 5 weeks, you put 5 in here. If it's 0 weeks, just started, you put 0 in here, right? So that's how you can figure that out. Total load is equal to $600 minus $40 times the number of weeks. Graph this information now, okay? What do I need to do to graph a couple things? So don't write down what I'm doing here, but there's a couple things I need to graph. 1, I need to label the axes. So label the axis. This is x-axis. This is y-axis. Okay. Take the time now. I know it's boring to do sometimes. Do your graphs properly. This is going to bite you in the butt if you're not. It's a skill you need to practice. I don't care how good at it you think you are, you can get better. So one, label the axis. That's step one. Step two I now need to do is I need to label, find the independent value, because the independent value is always going to be y, right? So what is my independent value of this thing? My independent value of this thing is going to be, so what's going to be my independent value? That's the thing that's going to go on the y-axis, right? So why don't we say that is going to be the number of weeks, because I can set weeks to whatever the heck I want here. So why don't we go time in weeks. That's an independent value. And then this is going to be, why don't we say this is amount owed? Frankly, you could do it either way you want. You could put the amount owed on the y-axis too, but it doesn't matter too much. So now what I need to do is so that's step three is I found the independent, and that means the dependent, and I put them in the graph. Now what I need to do is I need to fill in the values of the graph. That is the fancy way of saying I need to label all of this stuff here. So let's use our brains. Don't just go going 1, 2, 3. That's not going to work. We need to use our brains, read the question before we go into it. I know that I need to go to at least $600. And I don't know how many weeks, but you could probably figure out, well, if she's paying $40 a week, can't I just do 600? Oops. 600 divided by 40, that'll tell me the number of weeks. Okay, so I know I need to go at least 15 up here. So I know I need at least 15 and at least 600 on the x-axis. Okay, so that's what I know I need to fill in on this graph here. So let's try and figure out nice clean numbers. First off, how many times does this graph go up? It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It goes 12. So I can't go up by ones here because I only go up to 12. So what I instead need to do is, why don't I make it twos? Why don't I instead make this 2? So 2, 4, 6, 8, 10, 12, 14. My 15 will be right here, 16, and so on. Okay. You want to try and get at the values you have, go at least halfway up the graph. So now what I do is, so I know I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I go 15 this direction. If I go 15 here, well, how much can I make each of those then? 600 divided by 15, that's going to be what, like $40? Yeah. So why don't I go up by $40, right? We're taking away $40 a week. That's going to make it really nice and easy to graph. 40, 80. I'm not even going to do that. I'm not even going to go 40 and 80. You saw how above how we can like skip some values, right? As long as it's still readable. This is $40. This is 80. This is $120. This is 160. This is $200. This is 240. This is $280. This is $320, $360. Skip 400. I'm at $440. Skip 440. I'm at $480, $520. Then 560. This is $600. Okay. So first off, here's what we know. Now we need a couple points, right? So first off, I know that on week 0, step 4. Step 4 now we need to do is label 2 points of the line. Okay, that means we can draw our line. So step 4 is find 2 points, and then step 5 is just going to be draw the line. So first off, here's what I know. I know that at week 0, I owe $600. At week 1, I owe $580. At week 5, I know I'm going to owe $400, and so on and so forth. Don't just do week 1, week 0, week 1, because then you have lines like this. That's very hard to draw a full line. So go out. So week 10, I'm going to owe $200. Okay. So let's deal with a big value here. Let's go with the small value. So on week 0, down here, I'm gonna owe $600. On week 10, I'm gonna and that yeah. So okay, so this is point 1. So we 0 and then $600. And then what I also know is that I need to, and then on week 10, I'm gonna owe $200. I now have 2 lines that I can connect with a ruler. I'm gonna keep extending that out, right? Oh, look at that. It ended on week 15. I know this is when I'm gonna pay everything. Cool. Okay. So now just label your line, right? I'm just gonna say this is line 1. Sure. Done. I've graphed the information. What does the slope of the line, what is the slope of the line? What does it represent? The slope of the line represents how much money I owe over a period of weeks. So on week 0, I owe $600. In fact, I probably should have flipped this graph around. I should have actually had this as the amount at the time, but oh well. But that's what this line represents. So question 6, George works in a furniture store where he earns a commission of 12% on all of his sales. Calculate how much commission George will earn if he makes sales of 500%, or sorry, $500, $1,000, $2,000. Okay, so commission that's money on the top, right? If I sell a $100 car or $100 like a gift card, I get $12 in my pocket. Okay, this is something that a lot of businesses do to get their salespeople to sell more, because if they sell more, they earn commission on it. They earn more money, right? So all I need to do to figure this out is I need to take $500. 12%, isn't that just that? 12 over 100%, 12 over 100, that's what percent means, or times 0.12. 500 times 0.12, $60. I earned $60 on $500 of commission. On $1,000, well, isn't $1,000 same thing? 1,000 times 0.12, gonna get $120. You can use your calculator for that, or you can just realize that this is double that. For 2,000, same thing, times it by 0.12. You can times it by the fraction too, that works too. I'm gonna get $240. Write an equation that shows the relationship between his sales and the commission. Oops, erase this. So first off, write an equation that shows a relationship. Well, we're trying to figure out his commission, right? So his commission is going to be equal to, how do we figure out commission? We figure it out by taking 12% times, remember 12% is just the same thing as 0.12. So it's, so 12%, 0.12 of his sales. That's it. 0.12 times the dollar figure of his sales. Ooh, that's it. That's my formula. Done. Formula. All this is saying when you say you have an equation here is turn math into English. Okay. What is the independent value? The independent value, if you scroll up, is something you can set to whatever the heck you want. I can set his independent value here is going to be the dollar of his sales. I could say he sold $10,000 of stuff there. I could say he sold $5 of stuff, but his commission money is dependent on this. It depends on how much he makes and his sales. This is not a changing thing. It's not saying that, oh yeah, he earned 80%, 20%. Nope, it's 12%. That's it. So my independent variable is just my sales. Okay, question 7 here. Mariah is filling a rectangular swimming pool with water. She knows that the pool will hold 13,500 gallons of water. After 45 minutes, she estimates that there's 50 gallons of water in the pool. At what rate was the pool being filled? So there's a couple things we could do. One, I'm going to suggest we could turn this minutes into hours if we want. I'll try and do it both ways. So here's what I know. I know that when the pool is full, so here's what I know. I know that in 45 minutes, In 45 minutes, you know what? I'm just going to go ahead and make that into actually, no, I'll leave it as 45 because I'm going to guess a lot of people did it this way. So in 45 minutes, it filled up 2,250 gallons of water, right? I also know that the pool holds 13,500 gallons. So I know that this number got times by something to get 13,500. So just figure that out, right? How many times does that go into it? 13,500 divided by 2,256. So this number got times by 6, which means this number gets times by 6. Now, here's where it's going to be kind of a pain in the butt though, right? This is why I recommend you turn it into hours first. I can't just do 45 times 6. Oh, it's 270 minutes. Well, okay, actually, no, it is 270 minutes in this case, but you have to convert this. If you want to convert this into hours, you'd have to like remember that there's 60 minutes in an hour. But okay, so what's the rate the pool's being filled? Cool. I know that I can just times this by 6, but that's not what it's asking me. It's asking me for if it's asking me for what about if this was 1 minute though, right? What if this is 1 minute? So I know that this got times by 1 divided by 45. I'm just going to say this. This got times by 1 over 45, right? Like, don't be lazy. Keep it in a fraction form because it's going to change your answer otherwise. So that means I take this number, I times that by 2,250. Okay. I go up 50 gallons per minute. So what's the rate the pool's being filled? 50 gallons a minute. That's my answer. So I know how long it's going to take me to fill the pool. Oh, I just did this. This entire question could just be down there. Again, guys, this is why we read the question. I make mistakes with it too. So B is just this thing right here. And A is just, you figure out how many times it takes 1 minute or 1 hour. That works too. Question 8. Tom is a long-haul truck driver on the first leg of his trip. So on trip 1, he traveled 380 kilometers in 5 hours. If he drove at a constant speed, remember, constant means it never changes. If he sit on cruise control and there's no jerk driver who got in front of him to make him slow down, what's his rate of travel? So if he drove at a constant speed, what's his rate of travel? Well, here's the thing. If I know I drove 380 kilometers, and if I know I did that in 5 hours, isn't this going to give me his speed? Speed is just distance. Speed is just distance divided by time, right? Not 5 kilometers, 5 hours. So take 380 divided by 5. You do that, you're going to end up with 76 kilometers an hour. After the 5th hour of his trip, he sped up. After 9 hours, he traveled a lot. He traveled a total of 764 kilometers. So after the 5th hour, he sped up. He went a total of 9 hours. And he drove 764 kilometers. Okay. So I know that in 5 hours, he drove 380 kilometers, but he sped up. I don't know how much he sped up by. So let's figure out the actual distance he needs to go. It's not 764. We know that so he sped up at hour 5, we're at hour 6, hour 7, hour 8, hour 9. We know that in 1, 2, 3, 4 hours. So first off, we know that there is a total of 4 hours. And we know within these 4 hours, he drove 764 kilometers minus this number, right? Because this is what he drove before. So if I want to figure out how far he drove now, it's 764, subtract 380. He drove 384 kilometers in 4 hours. So now it's just the same thing, right? 384 divided by 4. This is his speed. This is his time. 384 divided by 4 is going to give me 96 kilometers an hour. This is his average rate of travel. Okay. Let me just erase this. Question 9. Last question. Myram is reading a book at a rate of 0.6 pages a minute. How long will it take her to read the entire 321 page book? Okay. So I know I go 0.6 pages per 1 minute. And I'm trying to figure out how long X it's going to take me to go 321 pages. Oh, that's easy. 0.6 times something got me 321. So how many times does 0.6 go into it? 535. Which means I take this 1 times it by 535 to get my answer. Well, 1 times 535 is just going to be 535. So it's going to take me 535 minutes. Oh, okay. So the question A is done. Now we look at question B. After 2 hours, how many pages will she have read? We have an issue now. We did it in minutes. We have hours. We need to figure out a way to solve this. So here's what I know. Let's use what I know. I know that she can read 321 pages in, not in this minutes, in a certain number of hours, because we need hours now. So let's figure out how many hours are in this. So I take my 535 minutes, divide it by 60 minutes. So 535, there's 60 minutes in an hour. It took 8. And again, keep it as a fraction if you can. 8 and 11/12 of an hour. So that's how many hours are in here. So it took 8. Yeah, I'm just going to leave it as 11/12 for now because it'll just keep, it'll be an easier answer. So I want to know, how long does it take me to get to 2 hours? If I read 2 hours, how long does that take me to figure out how many pages I've read? So after 2 hours, how many pages does she read? So that means I took this 8 and 11/12, I times it by something to get to 2. Figure out what that is. 2 divided by 8, oops, by backspace, by 8 by 8 and 11/12. So there's an 18 up here. I don't need that. There we go. 0.224. Which means I times this side by that. So times 321, 72. So how many pages did she read in 2 hours? 72 pages. You could have also used this figure here. This is 1 minute. This is 120 minutes. You times it by 120 as well. That would also work. But I know it took me, I read 72 pages in 2 hours. Okay, so keep going through with this. Do the review. You have the answers up on the LMS. Don't get lazy. Do the homework.